Hi everybody, this is the Old New Wildlife Trust and this is Wildlife Week. I'm Tom Amasso and today I'm going to be talking to you about bees and disease. So, bees are a really diverse group of insects. You probably know some of the more common ones. So you'll recognize the European honeybee and the common buff-tailed bumblebee that's resident in the UK. And most of these species do fall within the group, the family Apidae, including all bumblebees and all honeybees. However, there are other bees you might run into, even on Alderney. So this is the carpenter bee, and this is the ashy mining bee. So as probably most of you know, pollinators are facing massive declines at the moment. And this is for a variety of reasons. And scientists will give you lots of different figures. One I've got right here is that 78% of temperate plants are at least partly pollinated by insects. Out of our crops, we have 84% of our crops might be pollinated in part by insects, principally the European honeybee, Apis mellifera. And however, they're experiencing consistent declines worldwide. And so this all came to a head in the early noughties with colony collapse disorder in North America. And this is when suddenly honeybee colonies all over the country started mysteriously dying over winter. And so scientists and everyone at that point were trying to scramble and try and attribute these collapses to something in particular. So they came up with a variety of reasons. So the first one, and who most scientists would agree is the main reason, is habitat loss and habitat fragmentation, and principally the massive loss of wildflowers, which is their main foraging resource. But that's not the only reason. Novel diseases have also had a big impact on pollinator declines. For example, we've got the deformed wing virus, which is vectored by varroa mite. And alongside this, other viruses such as Israeli acute paralysis virus is another big one. And also other types of diseases that affect bumblebees, for example, such as Apis cystis, Crithidia bombi, and the SEMA species, which I'll be talking to you about later. But that's not it. If that were it, maybe bumblebees and honeybees would be doing a bit better. But there are other reasons as well. We've got pesticide use. As you all know, pesticide is a massive part of agriculture these days, and though it may help with dealing with harmful insects, it also has very potent effects on pollinators and other species that we do want. So that's a big issue. And finally, that's a more slightly recent one, is antibiotic use. So antibiotics are used mostly in apiculture for honeybees to treat foul brood. But also wild pollinators, including bumblebees, might be exposed to antibiotics when they're foraging. So you might be wondering which of these was responsible for colony collapse disorder. And in reality, more and more scientists are agreeing that it's probably all these things. And worse than that, they're not just adding to each other, they are interacting with one another. So habitat loss will lead to the spread of novel diseases, because as habitat becomes fragmented and they lose their resources for food resources, they'll all be forced to concentrate in the same areas, thereby increasing the spread of diseases. Antibiotic use and pesticide use are going to weaken the bee, and both of these man-made chemicals can have immunosuppressive effects. And so in turn, this will increase the risk of transmission of pathogens between bees, amongst colonies and outside colonies. And finally, There's also been research that shows that antibiotics and pesticide use can actually work in conjunction, and while the bee might be fine while only being exposed to one of these two chemicals, when they're exposed to both, they just pretty much can't take it anymore. So what we're really seeing with these is it's a cumulative effect and multiplicative effect of lots of different stressors, and it's sort of become the straw that broke the camel's back, really. They were maybe fine for a long time, but all of these factors interacting with each other has just become too much in recent years. So, just have a quick aside about islands, and in particular Alderney, because we've got quite an interesting history with these here. As you can all probably tell from our recent situation in humans, islands can act as pretty good natural barriers to infection, as evidenced by the fact that we've remained COVID-free so far. Islands like Alderney might have a lower prevalence of parasites, including in bees, than in mainland counterparts. However, because of their small size, populations of bees on Alderney are slightly inbred, and they might have less resistance to diseases that they've not evolved alongside. So in particular, what's really interesting about Alderney is that we don't have the varroa mite. They're found almost everywhere in the world, and they were the ones that were originally attributed to be the causal agent for colony collapse disorder. And they vector RNA viruses, including the form bloom virus, which is a big one. Yeah, so that's really cool about Alderney, and I don't think anyone really knows exactly why we don't have them, other than that we're an island, and maybe honeybees are imported less here, so they managed to escape so far. But it's a really good thing, and Alderney's bees have been used in research, including at my old university, the University of Exeter, just for this very fact. So, my background. You guys watching this probably know me as the Conservation Officer for the Alderney Wildlife Trust, but before that, my main interests were in disease ecology, and I completed both my dissertation and my master's in bumblebee disease. So I did two experiments I'm going to briefly talk to you about now, involving one involving pesticide use and one involving antibiotic use in the buff-tailed bumblebee. So as I mentioned earlier, global pollinator declines are being driven by a variety of stressors, and those stressors include parasites and pesticides. So our study system here is the lovely buff-tailed bumblebee that you all know, alongside some of its gut pathogens, Crithidia bombi, Apocystis bombi, and the SEMA species. And the pesticide we're looking at is clothianidin, which is a neonicotinoid pesticide, which you might have heard of from the news, and has quite bad effects on bumblebee health. So we were wondering whether exposure to this pesticide would lead to increasing rates of parasites in bumblebees. So I'm going to skip over some of this, but essentially what we had was we had this lovely contraption here. That's a bumblebee colony. Usually they're below ground, but we had them in boxes because we bought them off the internet. And we exposed half of them to pesticide and kept half of them as control, and then let them live out a normal year in their life. And at the end of that time, we checked to see what disease they had. This is where they were spread out. And this is what the inside of a bumblebee colony would look like if you could see inside. They make these kind of waxy structures. So what we have is two different diseases here, Apocystis and Crithidia. And as you can maybe tell from the graphs, to reach full infection, so at the top here, 100%, it took a very long time. It took the full 8 weeks of summer for Apocystis to infect a whole colony. Whereas with Crithidia, within 2 weeks, almost all of them had it, and within 4 weeks, everyone pretty much had it. So it just shows the difference in how different parasites can affect at different rates. And then what we're most interested in was whether there was an effective pesticide. So for Apocystis, we didn't find any effective pesticide, which is a good thing. There might have been because of how we did our research, but still a good thing. And Crithidia, where we did find there was a significant effect of treatment, and that pesticide increased the chance of a bee of getting disease. So not a good thing at all. So to discuss, what did we find? Pesticide exposure affects the prevalence of this gut parasite Cryptidia bombi in bumblebees. However, it seems to have no effect on Apis bombi. And Apis bombi is an interesting one because it's one of these novel diseases that we don't know much about, that's suddenly way more widespread than we thought before. And either it's recently become widespread because of things like pesticides, or it's always been there and we haven't picked up on it until now. And my second experiment was on antibiotics, and this was the more in-depth one. And so antibiotics, they are used to treat American foul brood with antibiotics to control the infection at the larval stages. But they're also used to treat fire blight in pear trees. And bumblebees are likely to be exposed to this when they're not foraging. So it's these two antibiotics, oxytetracycline and streptomycin, and our study system is again Bombus terrestris. So I don't know how many of you know, but each and every eukaryotic individual, which is, that said, all of us, has a community of commensal or mutualistic microbes that live within their gut. And this just means that we're full of bacteria and other things that work together in a synergistic fashion to keep our health and our nutrition going normally. And in return, they get food and they get somewhere to live. So it's a symbiosis, if you will. And bees have this as well. In fact, they have quite a developed one, and it helps them fend off diseases. It helps them with their immunity. In particular, it confers resistance to Cryptidia bombi, which we were just talking about. But it's dependent on certain particular species. And when you are exposed to antibiotics, for those of you that don't know, it basically flushes out everything inside you. It's a very powerful chemical that will kind of kill a lot of what lives in your gut, in your tummy. So this is exactly the same concept for bees. And if it eliminates these this community of microbes, then we can wonder what is that effect is that going to have on their immunity. So this is my very high-tech master's research plan. There's a bee here. We exposed bees to these chemicals and then inoculated them, which meant give them a small amount of disease to see if that disease would take hold, based on whether or not they had been exposed to antibiotics previously. And what we found was that the likelihood of being infected with Cryptidia bombi did increase according to the amount of antibiotic that they were given, which is, perhaps slightly odd for some of you, because you would think, oh, you take antibiotic to treat a disease, but also antibiotics do have a lot of negative effects on health. So this bee has obviously been weakened by exposure to this antibiotic, which left it in poor health, which meant that the infection was able to take hold better than it normally would. Similarly, we tried the same thing with another antibiotic, and we weren't able to find any effect, which is, again, perhaps a significant effect. We're not sure, but maybe as a precaution, we should be using streptomycin rather than oxytetracycline. But then it comes to mortality, and this is if you give them enough antibiotic, nearly half of them will die. And these doses that we use are not crazy amounts. We use the kind of dose that they would spray on crops and that bees might come into contact with. So you imagine half of bumblebees foraging on this crop might die simply from exposure to it. And similarly, again, this time we did find an effect with streptomycin, so the other one. So even though it might not be contributing to the amount of disease they have, it is also able to kill just by itself as a chemical. So what do we know? We know that antibiotics despite what they're usually used for, can also increase the amount of disease in bees. And we also know that it can have a direct effect by essentially killing them. We also know from other studies that antibiotics have sublethal effects, which means that it doesn't quite kill them, but will weaken them. And taking into account what we also know with pesticides and habitat loss, then that goes some way to explaining why bees might be declining, because all of these small things that alone might not have a large effect on bee health, when put together, is enough to tip economy over the edge. So, what next? I don't want to toot my own horn here, but I did my undergrad research in 2017, and the very next year, the EU banned the use of some of the neonicotinoid pesticides that I was studying. I was like, all right, fair enough. My research is a bit invalidated by this, but we'll move on. Let's try antibiotics instead. In 2018, I conducted my research on antibiotics, and in 2019, the EU banned those very same chemicals I was investigating. So obviously someone in the EU was keeping quite a close eye on my research. So while this is quite a good thing, it is also a political issue. And a lot of what we have currently here in the UK, I'm not quite sure how that applies to Albany, but what we do have in the UK relating to bees comes from the EU. And a bit sadly, I guess, some of the last few holdouts on banning some of these chemicals did come from the UK. So the fear is that, amongst scientists at least, is that with Brexit, we might lose some of these protections and go back to using some of these harmful chemicals. So hopefully this won't happen, and people are campaigning, as you probably know, to keep bees protected. And similarly, across the pond, under Trump's administration, the Environmental Protection Agency rescinded its ban on the neonicotinoid pesticides and also increased the use of streptomycin and oxytetracycline in agriculture. So obviously, they've just gone in the complete opposite direction and are going full throttle with it, despite global pollinator declines having been a major issue for the past decade or so. But, there's hope. Hopefully things will continue to move in a good direction and we'll get these back on track. Anyway, that was my presentation. Thank you for listening, and you can get any questions to me at conservation@albionswildlife.org.